Hi everyone, this is Malini Rao here. Hope uh, everyone's doing good. And good morning, good afternoon, or good evening for from wherever you are listening. So, as part of the All Day Devops, I'll be presenting security tools in CICD Pipeline on the cloud. So, as part of the disclaimer, I'm not promoting or endorsing any cloud service provider or products in this presentation and ensuring responsible cybersecurity. As part of the agenda, quickly we'll look at what is DevSecOps or security for DevOps. We will also be discussing cloud computing and DevSecOps. We will also see quickly the cloud computing shared responsibility model and what are the latest data breaches on the cloud and the app layer. We'll see the lessons learned on the top threats in the cloud and the DevOps environment. We will also discuss about the robust and effective DevSecOps on the cloud strategy because some of the organizations might have DevSecOps on-prem, but we will look at DevSecOps on the cloud strategy. We will also see the typical CI/CD pipeline and how actually the security best practices should be implemented for CI/CD pipeline on the cloud. We'll discuss the security tools to be considered in CI/CD pipeline on AWS, Azure, and Google Cloud. If you have any questions, you can post it on the All Day DevOps Slack channel, and I'll be happy to answer your questions. So who am I? Quickly, I'm the cybersecurity professional with 2 decades of experience in information security, cybersecurity, and governance, risk, and compliance. And I'm the promoter of Women in Cybersecurity. And also, you can subscribe to my Twitter and LinkedIn accounts, which is mentioned here. In terms of what is DevSecOps, I would say it is more of a culture which is integrating security into the DevOps environment. So the goal of DevOps is to give development teams more ownership in deploying and monitoring their applications by automating infrastructure provisioning, right? So when we are saying integrating security into DevOps, that means you are making the development and operations team think about the security and how it should be secure and complying to the regulatory requirements. So when you are adding security to DevOps, you are actually adding the automation. Companies should create strong security policies and standards without slowing down the development process, because developers are always in a hurry to basically finish the build and then release it as early as possible, because as part of the DevOps environment and the agile software development lifecycle, you actually look for faster build and release process. So you, in the CI/CD pipeline, you see that it's hundreds and millions of codes that are built, and you do the release on a daily basis. So security folks needs to think in that faster manner. So you need to implement DevSecOps by creating security as code culture, where security is integrated within all phases of software development lifecycle, and DevOps practices, keeping regulations and security top of the mind while maintaining speed, agility, and innovation. So in traditionally, you used to have earlier waterfall methods where it used to take like 9 to 12 months of application development, but now when it has its DevOps, it takes like 1 day cycle time and smaller releases. So security folks, as I mentioned, need to come up with the strategies on how best can be security be embedded or integrated within the DevOps environment. Now talking about cloud computing and DevSecOps, cloud, when we are talking about cloud, organizations are more and more adopting the cloud environment, whether it's private, public, multi-cloud or hybrid cloud. So the most important characteristics and the reason the organizations are moving to cloud, it is because it's on demand, it is pay-as-you-go model, it is cheaper if you compare the CapEx and OpEx model with on-prem and cloud. and it is elastically scalable, and it's self-service, as well as it has enhanced flexibility. And the most important part is the rapid implementation and time to value, because cloud implementations can be rapid relative with on-prem variants. For instance, on-prem could take 3 to 4 months for you to go live, but cloud is immediate. You can, if it's a SaaS application, you can be relatively faster compared to your on-prem model. For example, Salesforce, you just plug in and you can subscribe and start using it. So when organizations can deploy their key applications quicker with a better return on investment, and impact is also realized more rapidly. So basically, also when it comes to cloud, you have enhanced and robust security without add-on applications. So organizations are adopting DevOps culture because of similar reasons, because DevOps on cloud is preferred by most of the organizations because of the speed of deployment, automation, security, and on-demand fits well with cloud computing models of SaaS, PaaS, and IaaS. The DevSecOps market is expected to expand at a compound annual growth rate of 31.2%, from $1.5 billion to now in 2023 to $5.9 billion, as per one of the research from Markets and Markets. Cloud deployment of DevSecOps offerings helps organizations with deploying code during the production process, providing enhanced security, performance, and scalability. And what we have seen is adoption of DevSecOps offering is highest among larger organizations due to faster deployment and release cycles, as well as need for early integration of security tools into DevOps process. So if you see cloud and DevSecOps goes hand in hand, because the strategy and the need for DevOps on cloud is higher, it is flexible, and it is scalable and rapidly implemented. So that's something which fits in well when DevOps goes on cloud. So this is the standard, if everybody might have seen this, cloud computing shared responsibility model from AWS, and later on, of course, Azure and Google Cloud also came up with their models. But when it comes to public cloud, definitely it's a shared responsibility model, wherein some part of the infrastructure and some of the services are managed by the cloud service provider, but most of the services are managed by the customers. So for example, client-side data encryption, server-side data encryption, network traffic, operating system, network and firewall configuration, customer application and content. So the data security and the security of your applications, the responsibility is that of the cloud consumer or the customer, and AWS or Azure or Google Cloud is going to only provide some of the services, and this needs to be clearly mentioned in your contract with the public cloud service provider, so that who is going to do what is clearly known. And however, the data security responsibility and ownership lies with the cloud consumer. So some of the latest data breaches on the cloud and app layer. So if you see some of the data breaches that happen, which happen through the application layer, is like Target went through a sophisticated kill chain, including exploitation of a vulnerable web application attack, which resulted in hackers stealing the names, mailing addresses, phone numbers, and email addresses. These are only a few examples. There are quite a few data breaches that happened throughout 2019, but these are some of the top ones that happened recently. Then there is JP Morgan, where vulnerability on website built, maintained by third-party vendor in support of a charity, which resulted in username and passwords for 76 million households and 7 million business accounts were stolen. Then you have Community Health, targeted a flaw in OpenSSL, better known as Heartbleed, which resulted in theft of social security numbers and other personal data belonging to 4.5 million patients. And these are some of the latest breaches that happen on the cloud. So if you look at Facebook, there were 540 million Facebook user records that got exposed due to one of the vulnerability in AWS S3 bucket, and a couple of quite infamous breaches that happened is Uber, which got fined multiple times for that breach happened on the cloud servers because the records included passenger full name, phone numbers, email addresses, and location. So what happened in case of Uber is two hackers compromised Uber's GitHub account, which contained access to keys to AWS, and hackers stole the PII of 57 million individuals held data for ransom, and was publicly disclosed late in 2017. So again and again, Uber is getting fined for this, and Uber actually did not inform about this breach, and due to that they got fined twice. Then there's Capital One, where a software engineer, ex-employee of AWS, it's a she, and she actually, Paige Thompson, who actually did the hack, and who formerly worked for Amazon Web Services, and then she was able to get the personal data of 100 million people, one of the largest thefts of data from a bank. And then there's Accenture, world's first cyber resilience startup, which said that AWS left at least 4 S3 storage buckets insecure, and as a result of this flaw, the data on the storage media was available for download. Then there are other organizations, there are quite a few, but these are only top ones, like Verizon, there's Booz Allen Hamilton, there's in the US, the US elections, and there are quite a few of them. So where you can see that these are majorly happening through the cloud service providers, and the customer has not secured it in a proper way as per the best practices. Instead, they have kept the bucket, like AWS S3 bucket, exposed, or the configurations are kept to the default and they are not being configured properly. So the top security threats in DevOps and cloud environment are application abuse and misuse is the major one. If you can have account takeovers, you can have bots trying to hack your account, you can have data security as a threat, you can have insecure application build. Your entire application build is not secure and you're just going and building it and you are not following the secure coding practices. And then you are having unauthorized access, you are sharing the passwords, you have risky applications, data and user access, and you have passwords stored in clear text, which I've seen quite a bit in the organizations, and stored on GitHub, Bitbucket, wherever you want. You keep storing it, which is not a good practice. You keep sharing the passwords to save the service time of AWS, Azure, or GCP. So I seen the developers sharing the passwords. Then you have API keys are exposed. Keys are leaked in many ways, such as hard-coded keys are still being used. Code repository misconfigurations, code repositories get hacked due to that. And mainly I've seen S3 buckets, Google Cloud Storage, or exposed databases such as MongoDB, Elasticsearch, Redis, leading to data leakage. You have misconfigured servers and unauthorized access. Risky websites are exposed to bad guys, and then threats from the insider attack, lack of cloud security awareness and user hygiene, breaking and entering attacks such as brute force attacks, remote code execution, container escapes, supply chain attacks, malware, cryptojacking, ransomware, leading to data breach. So now talking about the what should we do about it, right? I mean, since we are talking about DevSecOps on the cloud, so we need to make sure that the DevSecOps strategy as well as the cloud strategy are defined in a proper way, so that you have a tightly controlled environment and you don't get easily exposed to the hackers. So some of the top 6 strategies that you should consider is you should have seamless collaboration of security team with the dev and ops team. of on-prem and cloud environment. If it's a hybrid cloud, then you need to collaborate with both on-prem and the cloud team. And if it's only cloud, then you need to talk to, you have to have strong collaboration with the dev and ops team. Then security team's new role now is to be an enabler. You need to be faster and you need to be non-blocker. You need to make sure that you can automate as much as possible. So when you have your strategy for DevSecOps on cloud, then you make sure that you automate it as much as possible and work as one team with dev and ops team. Then you provide regular security training and learning for development and operations team to ensure application security best practices are followed right from day one, such as security by design, secure coding, programming principles are followed. Identity and access management principles are followed, such as least privilege and need to know access with no sharing of passwords. There are some good reward programs that are provided by Google Cloud, but I would say the organization should come up with the bug bounty programs, and they should reward for identifying vulnerabilities by inviting bug bounties from Bugcrowd or HackerOne, the leading bug bounty posts. And then threat hunting exercises are conducted on a regular basis, including the red teaming, blue teaming exercises. Visibility of data into the cloud and DevOps environment is critical, because if you can't see where your data is, so you can't secure it, right? So make sure that you know where your data is so that you can secure it. Encryption of data at rest and in transit, such as SSL, TLS certificate application and renewals in a timely manner is critical in a DevOps environment. Then continuous security automation checkpoints should be built into the CI/CD pipeline, which I mentioned in the introduction of DevSecOps, that it should be security as a code. So you should have all the checkpoints built within your CI/CD pipeline in line with the speed of DevOps, because you don't want them to slow down their build and release process. And then your feedback should be immediate, so that you can have success or failure of your pipeline execution based on the security checks and repeatable mechanism to push changes to the production. So all this should be built into the CI/CD pipeline. Then I would say, as part of your continuous security automation, you should have all these bullet points which I mentioned should be automated. Like software vulnerability testing, security at time of code build, commit, and before production code checks. Docker container security checks should be automated. Kubernetes orchestration security checks. Automate your deployment tasks, like artifacts that came in from Jenkins are once deployed, are the ones which are getting deployed on the production. You need to make sure that this process is automated as well. You should have self-service workflows and runbooks. You should have source code scans at the runtime for identifying, detecting zero-day vulnerabilities and automated patching. You should have self-healing capabilities built into the code, like the RASP kind of solution, real-time self-healing solutions. Then you have continuous auditing capabilities, compliance checks to regulatory requirements, including third-party vendor risk assessments performed on a regular basis. You should have cloud security monitoring, logging, alerting, and notifications for configuration changes, compliance audit, and hardening. So all these should be automated, right? You can't be doing manual process in DevOps kind of environment. So make sure that all this is automated. Then you should have a proper incident response process, including threat investigation should be implemented on a regular basis. It should be tested as well. Then you should have reporting, dashboarding, along with some of the important security metrics that should be available at the click of a button, and it should not be like it's taking days for to generate report and review the metrics. Now, this is the typical CI/CD pipeline where you actually, people say that the security should shift left, but I would say security should be throughout the CI/CD pipeline. Definitely it has shifted left, because earlier you used to do in the waterfall method, you used to do the security testing only once the development has completed. But that's not the case. Now you actually start doing the security testing as soon as you start developing your source code and in the GitHub or Bitbucket, and then you actually go into the build process where you build the tool, build the system using the Jenkins open source automation pipeline, and then you do the further testing where you do unit testing, integration testing, and security testing as well. And once you go into the Artifactory repository for storing your artifacts, and then you go into the deployment mode using Chef or any other deployment tools that are available, and then you move into the production. Once that moves to the production, you go and go live, and your application goes live and becomes operational. So when we are talking about CI/CD pipeline, the entire security checkpoints or hooks should be built into the entire CI/CD pipeline. So this is how you should have your CI/CD security checks validation built into the CI/CD pipeline. You should have regular static code analysis, code reviews are done. You have your dynamic code analysis that is performed. You have your passive penetration testing performed. You have active penetration testing performed. You have infrastructure scans that are performed on a regular basis because you don't want to leave out on the infrastructure part. And you should also be continuously doing this process because you don't want to get do it in kind of a waterfall kind of method. So this is something which I was mentioning, you should integrate security into the continuous delivery workflow. So some of the security best practices for CI/CD pipeline on the cloud is definitely software vulnerabilities for source code licensing version, including open source in CI/CD pipeline at the time of development, build, testing should be considered. So how do we check this? You have to perform static application security testing, dynamic application security testing, interactive application security testing, and real-time application self-protection, RASP. Then API security, because you have a lot of APIs. For example, if you're using open source security testing tools, or if you're using open source solutions, and there are many open source solutions that you're using in a CI/CD pipeline. So you need to make sure you are actually testing your APIs as well. And you can check it through the same process like SAST test and IAST. Then you have to test your cloud infrastructure vulnerabilities, where you do this by performing infrastructure vulnerability assessments. Then similarly, infrastructure as code vulnerabilities needs to be identified by doing the assessments. Then coming to containers and virtual machine images, that also needs to be scanned. I have seen many organizations, they just don't do Docker container or VM image scan, and they'll just keep using it as it is. And that's not acceptable because that's where a lot of breach happens on the cloud. Then you need to perform continuous auditing and compliance to regulatory requirements such as CIS benchmarks, PCI DSS, SOC 2, and other regulatory requirements. So you need to make sure audit and compliance as a code is embedded into the CI/CD pipeline. Then data visibility, identity, and access management, control over data what is traveling within your CI/CD pipeline. This needs to be ensured. You should have a good CASB solution, cloud access security broker solution, which is inbuilt and integrated into your CI/CD pipeline as well as your DevSecOps environment. I mean, the DevSecOps environment, it should be there so that it is there between your cloud and your hybrid cloud environment. Cloud monitoring, logging, alerting, notifications, this is also very critical, and you should check this in your public as well as private cloud. That should be enabled. Then you should have reporting dashboards with metrics capabilities so that you can see what is happening and review it on a regular basis. And it is also good for your auditors and compliance team. Sorry. Then identity and access management on cloud, you should make sure that proper user and role provisioning and user lifecycle management process is followed. And then you have, you follow the least privilege access principles and need to know basis principles, which are the best practices for identity and access management. And then for data encryption, for data security, you make sure that your data is encrypted at rest and in transit. Some of the standards and frameworks to consider is OWASP Top 10, which is well known for web applications and API. And then you should, the link is provided here, and then you can refer Cloud Control Matrix from Cloud Security Alliance. You can also refer to behavioral driven development framework for security, which is BDD security, which is a very quite well-known security testing framework that uses natural language. And then one of them is, the link is provided here, Areas Risk Open Source. Then NIST Cybersecurity Framework and Cloud Computing Reference Architecture, and then ISO 27018 for cloud service provider who process personally identifiable information. Then MITRE attack framework, or the MITRE attack framework for detecting and investigating advanced cyber threats. And this is mainly for threat hunting. If you're, I would say you should perform threat hunting, identify who are the threat actors, and then because most of the organizations are moving to threat-based approach where you identify the threat actors and then you work on them to make sure that you have mitigated those risks which are caused by those threat actors. Now coming to the major piece, that is the security tools to consider for the CICD pipeline on AWS, Azure, and Google Cloud. There are other cloud providers also. Sorry, I didn't mean that I have to not include them, but these are the top ones that are mainly used by the organizations across globally. So what are we doing here? We are looking at some of the major best practices that we saw and how is AWS, Azure, and GCP, Google Cloud doing on this. We look at some of the open source tools as well as commercial tools that are available. Cloud Security Command Center for Infrastructure Security. So AWS has a very good security hub that they have come up very recently, and where you can actually collect all the logs and information from various AWS sources, and it's a hub where you can get all the information and logs, and it collects and even connects to the on-prem SIEM solution. Then you have in Azure Security Center, and you have in Google Cloud Security Command Center, which is similar. I didn't mention open source and commercial here because these are inbuilt solutions which are mostly used by the organizations, but there are, of course, some of the commercial tools which can look into as a command center for your infrastructure security. And software vulnerabilities testing for source code licensing version, including the open source OSS in CI/CD pipeline at the time of development, build, and testing. So AWS has Inspector, which is quite good and used quite well within the organizations. In Azure, you have Secure DevOps Kit for Azure, which has all these capabilities. In Google Cloud, you have Security Scanner, which can scan the software vulnerabilities. Then OAuth Zap is an API-based scanner, but I would say it is quite good and used quite well by some of the organizations I've seen. And it integrates well. Currently, it comes for a few languages like Java, Python, Ruby, etc. The link is provided here, and you can download it and start testing it and plugging it into your CI/CD and do the scanning. So there are other like Gauntlet command line testing framework, which supports BDD syntax to allow readable and structured tests, which is also quite good. Both are good. OS Zap is also quite good. The API is limited, I have mentioned here, is because it's available for a few programming languages at this time. But what I'm hearing from the OS Zap team is they are coming up with more options. And commercial tools, we have CA Veracode for performing source code analysis. We have checkmarks for performing SAST, DAST, and IAST. We have Sonar Cloud for SAST, DAST, and IAST. These are some of the examples. There are quite a few tools available in the market, but these are the top ones. Then RASP, we have Contrast, we have Signal Sciences, we have Voratech. Then open source vulnerability scanning is very critical, and we have white source for that. Even Veracode does open source vulnerability scanning, but white source does specifically open source. So that's the reason I mentioned here, and quite well used by the organizations. Then we are coming to the container security. AWS has nothing inbuilt. Azure also does not have yet. I did check with them during one of the Azure conferences with the team, and they said they're still in the pipeline. And then on GCP, they have it in form of Kubernetes orchestration, which offers container security. Coming to open source, there is a very good tool called Claire, which is an API-driven static container security analysis with a huge CVE database, and the link I have provided there. Then there is OpenSCAP, then Anchor and Dagda is there, which are some of the container security analysis tools. Then in commercial Aqua Security, which is available in AWS Marketplace and Azure Marketplace, so you can integrate and use them in Azure and AWS environment because there's nothing inbuilt. Now, visibility into cloud is very critical, including your CI/CD pipeline. So AWS Macy has some capabilities of data discovery and data classification, but it's not all the capabilities that we are looking for here. So what I'm saying is mainly the CASB kind of solution is not available out of the box in AWS Cloud. And Azure has come up with Azure CASB. They have SOC capabilities in terms of Azure Sentinel, and you have Azure Security Center. GCP does not have inbuilt, it integrates with the commercial tools. So commercial tools that are available is Netscope, Sky High Networks, Twistlock, Dome9 Security, McAfee, CyberArk. There are many other tools, but these are the top ones. Identity and access management, AWS has IAM, Azure AD in Azure, and GCP IAM in Google Cloud. And if you're looking for commercial, there is Okta IAM, which is a cloud-based identity and access management solution, which you can use if you want to integrate with your enterprise IAM with the cloud IAM solutions. Then encryption of data at rest and in transit. AWS uses encryption for EC2 and S3 storage buckets. And then it has key management systems where you manage your keys in a secure manner. And Azure also uses encryption, but they don't have a specific service there. It's part of the security center. So sorry, I didn't mention security center here, but I'll update the slides. It is Azure Security Center, and then GCP, Google Cloud uses AES 256-bit encryption and key management services. Cloud infrastructure level controls like firewall, load balancer, DDoS attack, monitoring solutions. Of course, you have virtual private cloud in AWS, in Azure and GCP also it's available. And commercial, it's available like Palo Alto, Checkpoint, McAfee, which are cloud specific options available. And they are available on the marketplace. Cloud security monitoring, threat detection and response. You have Amazon Inspector, AWS Cloud Trial, AWS Config, Amazon Guard Duty, AWS Security Hub. So I'm not going into details of each and every tool because of the time limit. Similarly, you have it on Azure Sentinel, Azure DevOps Kit, Azure Security Center, which does the similar thing. And then Google Command Center, which also has the capability to do monitoring, threat detection, analytics, and response. OSIM is one of the open source SIM solution, but it's not widely used for cloud specific kind of environment. Then you have Threat Stack, Alien Vault, Evident.io, CASB solutions, and Splunk. Sorry. Now coming to cloud security reporting dashboards and metrics, you have AWS Macy, Azure DevOps Kit in Azure, and you have what is called as in Google Cloud, you have something called, if you go to status.cloud.google.com, you get the status of our entire cloud infrastructure, including the dashboards and metrics. In terms of open source, you have Caverian cyber exposure, cyber posture intelligence, which can be used for reporting dashboards and metrics. Secure DevOps Kit for Azure is a really good solution, I would say, when it comes to Azure environment. Basically, it offers subscription security, it offers secure development, it offers continuous integration and continuous deployment extension. It offers continuous assurance, alerting and monitoring capabilities, and telemetry dashboards. So everything that we were mentioning that as part of the best practices, if you see it, it's there integrated in Secure DevOps Kit for Azure. So it's quite good, I would say. And these are some of the stakeholders who can actually be benefited by using Azure Secure DevOps for Azure. Now, of course, I can mention the tools are quite, some of them are really used well by the organizations. You can go to some of these references and understand the tools. Like if you go to OWASP, ZAP Attack Proxy Project, you can download the proxy tool and start using it for security scanning. It's an open source tool. You can actually go to awesome DevSecOps resource on GitHub and find out there are lots of webinars and a lot of resources where you can understand DevSecOps in a proper manner, which is also useful for your development and operations team to go through them so they can start thinking about how and where they should integrate the security. Then you should have OWASP top, you should refer to the OWASP top 10 risks on the OWASP page, and you should also refer to the Google, Amazon, and Microsoft security pages that they have. Then Cloud Security Alliance has a working group for DevSecOps. You should join that and start looking into some of the development that is happening in that area. So question and answers, since I am recording this offline, I would say if you can post it on the Slack channel for All Day Devops, ADDO, and in the DevSecOps channel, then I'll be able to answer and happy to answer your questions. Or you can ping me directly on the Slack channel. And these are some of the sponsors of All Day DevOps, and thanks to them for sponsoring the All Day DevOps. That's all for today. Thank you very much and have a great day.